today we're going to talk about solving special systems. Um, the first type of system we're going to be talking about is a consistent system, and these are the ones that we've been looking at over the past few classes. These are systems with at least one solution where you have, if you were to graph the system, the lines would meet, they would cross at some point. An inconsistent system is a system that has no solution, and these are parallel lines. And as we know, parallel lines never meet. So let's take a look at this first system. We want to solve the system y equals negative 2x plus 5 and 2x plus y equals 1. And we've learned 3 ways of solving systems. We've learned to solve them by graphing, substitution, and elimination. It's entirely up to you which method you want to use here. Since I have a variable that's already isolated, in this case my y, I'm going to use substitution. And that doesn't mean you couldn't use another method if you wanted to. So I'm going to substitute negative 2x plus 5 in place of y in the second equation. So I'm going to have 2x plus negative 2x plus 5 equals 1. And the thing that's going to happen here when we go to combine our like terms is the 2x and the negative 2x cancel. And I end up with 5 equals 1, and that's kind of silly. That makes no sense because 5 doesn't equal 1. And we've encountered this before when we were solving equations at the beginning of the semester, or I should say at the beginning of the year, where there was no solution. We got something like this that didn't make any sense, and we're going to say that this has no solution. In fact, we call this system inconsistent. So we also would know that these are parallel lines because that's the only way you would have a system of 2 equations with no solution. So this is some information we could list about that system. Now let's solve the second system. We have y equals x minus 3 and x minus y minus 3 equals 0. So again, I would choose substitution to solve this system because we have our y isolated. And so if that's the case, I'm going to take x minus 3 and put it in place of y. Now remember, this is like having a negative 1 here in front of the y. And the reason I'm putting that in is because I'm going to need to put parentheses around that x minus 3. But I plug it in place of y. Now remember, I also have this minus 3 here, and it equals 0. I'm going to distribute the negative 1. So I have x minus 1x plus 3 minus 3 equals 0. Now, we have a situation here where our x's are going to cancel. This is really like having a 1x. 1x minus 1x, that cancels. And we have 3 minus 3, which cancels. And so really on the left-hand side we get 0. So we have 0 equals 0. And if you remember, we talked a little bit about this later in the semester, first semester. If you have something like this, if you get this result, these are really the same line, each of these. And basically what's happened is we've just put them in a little bit different form. These are the same line if you get the same answer on each side, and there is an infinite number of solutions. Okay? So going back to what we listed here at the top of the page, let's see which category this falls into. Systems with at least one solution. Now, at the beginning, I didn't really talk about anything except the kind that just had one solution. The systems with at least one solution. If you have one line, and I didn't graph that very straight, but if graphed over the top of the other same line, there are an infinite number of points where these lines meet. And so there is indeed at least one solution. There's really an infinite number. And this is a consistent system. Okay? Now, number 3, we're going to leave for class time. Let's move on to our next page. And we're going to talk about some other types of systems. We want to talk about an independent system. An independent system has exactly one solution, where your graph is just two intersecting lines. It's not at least one, it is exactly one. A dependent system has infinitely many solutions. That's like what we looked at in the last problem. The graph is two coincident lines. Coincident means that they both occur in the same spot, one right over the other. Okay? Now, we want to classify each system here and give the number of solutions. So we want to think about how we want to solve this. If you want to use substitution, elimination, or graphing, I would probably use substitution in this first problem because I can get my x isolated very easily. So I'm going to solve 3y equals x plus 3. I'm going to solve for x. And I'm going to do that by subtracting 3 from each side. So I've got 3y minus 3 equals x. And then what I'm going to do with that is I'm going to substitute it in place of x in the second equation. So I'm going to have negative 1/3 times, in parentheses, don't forget the parentheses, 3y minus 3 plus y equals 1. Okay, now I need to solve it. I need to distribute negative 1/3 through the parentheses. Well, negative 1/3 times 3y, the 3's are just going to cancel, so I'm going to have negative 1y. Negative 1/3 times negative 3, that's just going to give me, I'm sorry, positive 1. I was looking at the 3's. Positive 1. 1/3 of 3 is 1. Negative times a negative is a positive. Then I've got positive plus y here. That's like having a 1y equals 1. And the negative 1y and the positive 1y, they cancel out. And I'm left with 1 equals 1. And we saw in the last problem that we did that when you have the same answer on both sides of the equal sign, that we know that this is actually the same equation. So which means these are coincident. Coincident lines. There are infinitely many solutions because they meet at every possible point on their lines. Infinitely many solutions. And going back to the top of the page, to classify it, it is a dependent system because a dependent system has infinitely many solutions. Now let's look at problem number 2. We have x plus y equals 5, and 4 plus y equals negative x. Okay, and again, I would probably use substitution to solve this because it's pretty easy to get either x or y alone. I'm going to solve the first equation, x plus y equals 5. I'm going to solve it for y. It really doesn't matter which one I use. I'm going to subtract x from each side. So I have y equals negative x plus 5. So now I'm going to take negative x plus 5 and I'm going to plug it into the second equation in place of y. So I've got 4 minus x plus 5 equals negative x. I want to get all of the x's on one side, but first I'm going to combine my like my like terms. So I've got 4 plus 5, which gives me 9, minus x equals negative x. Excuse me. I'm going to add x to each side, and you notice the x's all cancel out. So really on the right side I have 0, and I end up with 0 equals 9, which we know makes no sense at all. Okay, so because 9 is not equal to 0, and we know that means that there is no solution at all. Okay, so if we go back to our types of systems we have here, it's definitely not independent because it does not have one solution. It's not dependent because it does not have infinitely many solutions. But going back to what we were looking at before, I'm just going to go back to our previous page. Let's take a look at that. We did have a category that fell into something called an inconsistent system, because that has no solution. So let's go back to our current problem. I'm going to pull it back down, and we're going to say that this is inconsistent. And we do know that that means we have parallel lines. Okay? Now, when we come back to class, we are going to try some more of these problems and this word problem at the bottom of the page. So that's going to be where we start when we come back to the next class. Thank you very much.